RHS Pre-Calculus presents Trig Form of a complex number. So easy, a caveman could do it.
Hi, I'm going to be your teacher today. You'll learn how to convert a complex number in standard form to trigonometric form, then back from trig form to standard form.
But what is a complex number anyway?
A complex number is a value that contains the imaginary number I. I is equal to the square root of negative 1. It's usually written in the form z equals a plus bi. That's called the standard form.
Okay, then what is trigonometric form?
It's just another way to represent complex numbers as a point on an imaginary plane or graph. On this kind of graph, the x-axis is the real axis, and the y-axis is the imaginary axis. So in standard form, the point will have the coordinate a, b. For the trigonometric form, theta can have an infinite number of values, so it's usually bounded between 0 and 2 pi radians.
Okay.
From the graph, we can use these following equations. A equals r cosine theta, b equals r sine theta, r equals the square root of a squared plus b squared, and tangent of theta is equal to b over a. Now let's learn how to convert from standard to trigonometric form. Let's use a complex number, z equals 2 minus 2 root 3i. First, we have to graph it. Remember, the real number, 2, is the coordinate on the x-axis, and the coefficient of the imaginary number, negative 2 root 3, is the coordinate on the y-axis. So the point should be 2, negative 2 root 3. R is the distance between the origin and the point. We can find this by using the Pythagorean theorem, which is how we got this equation. Plug in 2 for a, and negative 2 root 3 for b. If we solve the equation, we see that r equals 4. Now we need to find theta. To do this, we use the equation tangent of theta equals b over a. Again, let's plug in 2 for a and negative 2 root 3 for b. The 2's cancel out, and we get negative root 3. To solve for theta, we find the arctangent of negative root 3, which ends up being negative pi over 3. But since theta is bounded between 0 and 2 pi, we use the equivalent, which is 5 pi over 3 radians. Now we just plug in our values into the trig formula. Place r with 4 and theta with 5 pi over 3, and you get this equation. You can also write it in the form z equals 4 cis 5 pi over 3, which just abbreviates cosine plus I sine. This is the trig form of the complex number z equals 2 minus 2 root 3i. Now let's do it the other way around. Let's convert the trig form back to standard form. We'll reuse the equation z equals 4 cis 5 pi over 3. To find a, we just use the formula a equals r cosine theta. You plug in 4 for r and 5 pi over 3 for theta, and after solving, we see that a is equal to 2. To find b, we use the equation b equals r sine theta, and plug in the same values. The solution is b equals negative 2 root 3. You can see that we've returned to our original a and b values, which you can plug back into the standard formula of z equals a plus bi.
Isn't that the same as multiplying out the trigonometric equation?
Exactly, you can do that too.
Even a dinosaur can do it.